Hello, I am Shubhakar Naikji, lecturer in Polymer Technology, Karnataka Government Polytechnic, Mangalore. On behalf of Department of Collegiate and Technical Education, I am going to present PPT on copolymerization, free radical copolymerization, ionic copolymerization, and copolycondensation. This is related to Unit 2 and this is my first session. Program is Polymer Technology, course Polymer Science for third semester. Course outcome is at the end of the session, student will be able to understand the basic concepts of copolymerization and various techniques. Before I begin my today's session, let us have a quick recap of previous session. In our previous session, we had come across about introduction to poly-addition polymerization and ring opening polymerization. These are the two types of polymerization reactions we had come across in our previous session. In today's session, we are going to discuss about various topics like basics of copolymers, free radical copolymerization, and ionic copolymerization. And also, we will go through copolycondensation. At the end of this session, we'll have the multiple choice question and the answers for these questions. Now, question is what is a copolymer? Copolymerization is nothing but a reaction by which we can produce the copolymers. But what are copolymers? See, in some polymers, the backbone has different types of repeat units. If the backbone is made out of different types of repeat units, then such polymers are called heterochain polymers. Heterochain polymers are also called copolymers. Say for example ABS. ABS stands for acrylonitrile butadiene styrene. And another example for heterochain polymer is SAN, styrene acrylonitrile. Polyvinyl chloride vinyl acetate, a single polymer made out of two different monomers. As this is a copolymer, the backbone is a heterochain type of. So these are the examples for the heterochain polymers which are also copolymers. If the backbone is made out of entirely of a single type of repeat units, then such polymers are called homochain polymers. Say for example polyethylene polymer, we have only ethylene repeat units will be there throughout the macromolecule. Similarly, in polypropylene, only propylene will be there. One unit of propylene attached to another unit of propylene, like that. In polypropylene macromolecule, you can see number of propylene repeat units. So a similar type of single type of repeat units will be there in this type of polymers. Such polymers are called homochain polymers. Even in polystyrene, styrene is the monomer. Repeat units of styrene will be there throughout the macromolecule length, and that polymer is known as polystyrene. So basically heterochain polymers and homochain polymers. Heterochain polymers may be of copolymer type. If two different repeat units in a copolymer are distributed at randomly throughout the chain length, the polymer is called a random copolymer, because if it is made out of two different monomers, if you polymerize them, if you produce the copolymer, if the one type of monomer is at random in another, so throughout the chain length, then we call that type of copolymer as random copolymer. Now, one more type of, say, the repeat units are distributed alternately, one after the another. If we have only two monomers of different type, they are made to polymerize each together, and if you produce a copolymer, if the repeat units are distributed alternately one after the another, then that polymer is called a alternating copolymer. When block of one repeat unit is followed by block of another repeat unit, say we have one type, A type, let us say, second is B type. Number of A's together, many repeat units will be there. After that, many B's, another type of repeat units will be there. They are in blocks of same type of certain numbers, and another the certain numbers will repeat. So this type of copolymer is called block copolymer. And in some polymers, we can see a arrangement like backbone is or main chain is made of entirely one type of repeat unit, whereas the grafts or branches of the another type of repeat unit, then that type of copolymer is called graft copolymer. So let us discuss about the copolymerization with some basic knowledge. Two or more monomers or monomer pairs are polymerized simultaneously, then we get a copolymer. Polymer is composed of more than one repeat units, or usually will be there in copolymers. Only one type of repeat units makes a homopolymer. If two or more different types of monomers are used in polymerization, then we call this a copolymer. Say example for copolymer is SBR. SBR stands for styrene butadiene rubber. Styrene butadiene rubber, it is called. SBR is a first commercially made synthetic rubber. It is a copolymer obtained by free radical polymerization of monomers called styrene and butadiene. This we can represent by the equation A and B. A is one type of monomer, B is another type of monomer. Say for example, styrene is A, butadiene B. And if you take X numbers of A and Y numbers of B, then we are going to get the product of this. And the copolymer formed is composed of both monomeric units A and B arranged at random. The A is to B ratio and degree of randomness depends on the quality of A and B. And majority of the commercially important copolymers are made by free radical copolymerization, ionic copolymerization, and polycondensation polymerization. These are three types of copolymerization reactions. Usually we make use for production of copolymers on commercial scale. Now, let us look into how the polymerization proceeds when an initiator is introduced. Two monomers, let us take M1 and M2. These are the two different types of monomers. If you mix them together and polymerize using a free radical initiator, In that, initially we have to hit the reaction mass with the free radical initiator. Now initiation of the process takes place. The initiator compound, it decomposes and it gives free radicals. These free radicals will now begin the polymerization process. The free radicals formed, which are maybe they are say going to react with these two different types of monomers. Now R dot, these are by the homolytic decomposition free radicals which are formed. One free radical will attack one of the monomeric unit, say M1 type. Similarly, another free radical will react, it is going to react with another type of monomeric unit, that is M2. Now let us see how the reaction proceeds as the initiation takes place. Now the linking up of these two will takes place like this. So this how it takes place we had come across in our free radical polymerization discussion. Similarly, another free radical which is going to react with the another type of the monomeric unit. Now this will form as these are the two initiated molecules or excited molecules. This stage is called initiation. In copolymerization, different type of initiated molecules are going to form. Whereas in the free radical polymerization or chain polymerization, only one type of free radical initiated molecule is going to form. Now in copolymerization, we are going to get different types of initiated molecules of the first stage of polymerization. Two polymer chains are thus initiated by M1 and M2 carry free radical sites as shown here. Now, how the propagation takes place? Chain propagation proceeds as given here. Now, the free radical sites present over M1 and M2 are given in this in different manner. See, the initiated molecule, that is M1 type, will come in contact with a fresh monomer of M1 type. That will now shifting of this free radical site takes place to this, linking up of these two takes place, thereby RM1 star or dot. This way we can represent it. This is the now growing chain. So we say this is the propagation reaction. Here one type with the one type, similar type, is going to react and is going to form a lengthy macromolecule. Say propagation type 1,1, we say type 1,1. In the probability of the second type, that is the same type of excited molecule, initiated molecule, in other words, that will come in contact with another type of a different type of monomeric unit, that again will be linking up of this takes place and the free radical site will be shifted to the M2 unit, a monomer unit, and thus propagation proceeds. Here one type of the monomeric unit links up with the another type of monomeric unit, therefore the propagation of this type is called 1,2 type. Now in the third point 3, you can see this type of possibility. This is another, the RM2 dot, this is the another excited molecule, initiated molecule. This comes in contact with the fresh monomeric unit of different type, that is say M1 type. Now here also free radical uh, initiation initiated molecule, this will come in contact and the propagation proceeds. Free radical site will be shifted. A covalent bond is going to form in between these two molecules, and hence a bigger molecule is going to form. And here this propagation is called PR, propagation type 2-1, because the second type of monomeric unit is the initiated monomeric unit is going to form a link with the another type of monomeric unit. So it is PR type 2. Now fourth possibility is this initiated molecule, another monomer initiated molecule that will come in contact with the similar monomeric unit. Then again the linking up of this will take place, as you could see here. Now this is propagation type 2 we call. So there are four possibilities, as you can see over here: type 1, 2, 3 and 4 type, and propagation type 1, propagation type 1, 2, propagation type 2, 1 and propagation type 2 is simultaneously going to form. So number of macromolecules are going to grow in this propagation stage. These are the four possibilities. All the four types of addition takes place, as we have shown in our previous slide. The possibility of all the four types of propagation with the rates of these four propagation reactions are given below. M1 dash or M1 dot plus M1, it is the rate of this propagation is denoted by K11. It is going to yield M1 dot. So we can write similarly the another type, that is M1 dot plus with the M2, a different type. This is with the K12 type of say at the rate of K12, it is going to form M1 M2 dot. A third possibility, that is what we have seen in that M2 dot type with the M1 type, it is going to link up with the rate K21 and it forms M2 M1 dot. And the fourth possibility is M2 dot plus M2 with the rate of reaction K22, it is going to form M2 M2 dot. Say the reactivity of the any growing chain that depends on the end monomer unit carrying the free radical site. So the reactivity is shown over here. We can write R11, that is K11 M1 M1 with the brackets we write. So reactivity of 1, 2, that we can write K12 M1 and M2 dots in brackets. Similar reactivity of third one, that is the R21 is equal to K21 into M2 M1 dot. So the fourth one is we can write R22, that is equal to K22 M2 M2 dot. So these are the four growing chains and the reactivity of them is given by the R12, R21 and so on. The rate at which monomers M1 and M2 are consumed during the propagation step is given by the derivative equation minus d of M1 divided by dt, that is equal to K11 M1 dot into M1 plus K21 M2 dot M1. Similarly, the minus dm2 divided dt is equal to K12 M1 dot into M1 M2 plus K22 into M2 dot into M2. This is the rate equation of M1 and M2 monomers when they are consumed during the propagation step. Now, at a steady state, the rate of particular chain end disappears, that is equal to the rate of formation of the same chain at the end. So we can write K12 is into M1 dot into M2, that is equal to K21 into M2 dot into M1. So M1 by M2, M1 dot divided by M2 dot is equal to K21 into M1 divided by K12 into M2. This way, the steady state equation we can write for this copolymerization type of reaction. And the combination of all the above equations gives the polymer equation. So K11 divided by K12 is the reactivity ratio. Similarly, K22 divided by K21 is the reactivity ratio. Now, let us have a quick look of the multiple choice questions of today's session number 1. Question number 1. If the backbone of polymer is made of different types of repeat unit, such polymers are called dash. Homopolymer, heteropolymer, mixed polymer, none of this. The correct answer is heteropolymer because polymer backbone is made of different types of repeat unit. The correct answer for this question is heteropolymer. Which is not a copolymer? ABS, SAN, polyvinyl chloride, SBr. ABS, of course, it is having acrylonitrile, butadiene and styrene. So it is a copolymer. SAN, styrene acrylonitrile, this is another copolymer. SBr, styrene butadiene rubber. So answer A, B and D are copolymers, but here it is asked which is not a copolymer, polyvinyl chloride. Only vinyl chloride monomers will take part in the formation of polyvinyl chloride. Now question number 3. If the chain backbone is made entirely of single type of repeat units, such polymers are called dash. Homochain polymers, heterochain polymers, mixed polymers, none of this. The backbone is made of entirely a single type of repeat unit. Hence, the answer should be the homochain polymers. Which among the following is not a homopolymer? Here, answers are given. Polyethylene. Of course, it is made out of ethylene monomer only, so it is a homopolymer. Polypropylene. It is made out of polypropylene monomer and it is a homopolymer because only one type of monomer is employed in the production. Polystyrene. Styrene is a monomer from which it is been made. No other monomers except styrene take part in this polymer formation. Hence, answer A, B, C are homopolymers, which is not, SBr is not a homopolymer. Now, question number 5. When two different repeat units in a copolymer are distributed at random throughout the chain, the polymer is called dash. Block copolymer, random copolymer, graft copolymer, homopolymer. See, the different repeat units are distributed randomly. Hence, the answer must be random copolymer. Question number 6. When two repeat units are distributed alternately throughout the chain and the polymer is termed as dash. Answers are alternating copolymer, block copolymer, random copolymer, and graft copolymer. Here in this question, what is asked, two repeat units are distributed alternately. Alternately means one type of repeat unit, after that another type, again the third one is the first type and fourth one is the second type. Likewise, alternately both the repeat units will appear in the backbone of polymer. So hence the answer must be alternating copolymer. Now question number 7. When block of one repeat unit is followed by block of another repeat unit, which in turn is followed by block of first repeat unit, and so on, the polymer is called dash. Block copolymer, random copolymer, graft copolymer, homopolymer. Then the question, it is said block of one repeat unit is followed by block of another repeat unit. So block in the sense the same type will be in numbers, many numbers, and the second type of monomeric units will be again in different numbers in the same backbone of the chain. Hence it is called block copolymer. Thank you.